So far we've done all of the transformations we've done have been what one would consider a rigid motion or an isometry or a congruence transformation. Today we're going to look at dilations, which is the last transformation we're going to do this particular year. And a dilation is not a congruence transformation or isometry or rigid motion, whichever word that you'd like to use. A dilation is actually what would be considered a similarity transformation that either enlarges or reduces the size of the pre-image by some given scale factor. And I think it's helpful to think of this as we're looking at a lot of times distances here or lengths. So take a second to get that down again. Probably the key words there is a similarity transformation, but it does transfer it. It moves or maps points from one place to another, and it either is going to enlarge or reduce the size. Notice it doesn't say anything about the shape. And I am recording this without a group to watch. This is not live, so if I get going too fast, just feel free to pause the recording whenever you need to. Okay, a scale factor then is basically what are we actually going to multiply by to get from the pre-image to the image. Perhaps I would multiply distances by 2, or perhaps multiply by a half, or by 5, or 1/3, or lots of various numbers. I'm probably not going to multiply by 1, because if I multiply by 1, that's just going to be a congruence. Because you multiply anything by 1, you end up with what you started with. So a lot of times the scale factor in our problems is going to be represented by a lowercase k, and that'll tell you what the scale factor is. Unless it specifically says this is the scale factor. The center of dilation, some of you that are in art class may know by a different name, but it's the point used in dilating. It's kind of like our central point. It's our reference point is another way of looking at that. Those of you in art class may call that the vanishing point in some of your pieces that you've done. So just to give you a very just general start off, if I was on a number line, so let's say we got 0 and 1, 2, 3, 4, 5, let's go a little bit further, maybe 6. And let's say you said the center of dilation, you just pick a spot, we'll say he is here at 1, is our center of dilation, we'll say is right there. And we'll say that the pre-image is over here at 3. We'll call this maybe point A here and then point B. So B is our pre-image. A is our center of dilation. And let's say I told you the scale factor, or K, was, we'll pick a nice easy one for this one, 2. All right? And it might be a good idea to get this in your notes. This is a nice starting one, but sometimes these are the ones that confuse students. So the center of dilation, or my reference point, is A. B is my pre-image. Right there. So there is a distance here, a distance of, well, 2. What I would like to do is take that distance and multiply it by a scale factor of 2. So now this distance needs to end up being 4, is where the image should end up being. Again, starts at the pre-image, ends at the image. So again, I'm referencing A, though. So what it should happen is I should take this distance of 2, multiply it by the scale factor of 2. So now I know the distance that I'm concerned with is 4. So if I'm starting at 1, a distance of 4 would take me all the way over to there to 5. So maybe you would call this B prime, because that's where it ended up. It used to be only 2 units away, now it's 4 units away. Okay? And then in this case, if the scale factor was, say, a half, well then instead of going 2 units, I would only go half of that, which would be 1, so I would have ended up there at 2. Okay, it would have been half the distance of what it was before. So the key is using the center of dilation is more of a reference point, and then there's a pre-image that gets moved somewhere. Okay? And that distance between your pre-image and the center of dilation is what gets changed. Okay? They do go off on a line. Okay? Now, if this first one didn't quite make 100% sense to you, that's okay. We're just starting dilations. Perhaps when you see this next one, when it's not just a point, it will be a little bit easier for you. Okay? If you do not already have a protractor, you are going to want one. So go ahead and take a second and grab one if you don't have one. And what I've tried to do here, and again, with the software you can kind of see my lines in there, but we're going to use this one here, and we're going to say that our center of dilation for this problem is C. And sometimes in your problems, it'll be like the origin will be the center of dilation most frequently if we had an XY axis. And so we're going to try and basically dilate this by a scale factor of 3/2. Because I'm guessing a lot of you, when you heard the word dilation, you were thinking of your eyes. Perhaps when you go to the doctor, your eyes get dilated. In that case, it means enlarged so that they can see in your eyes. But in our cases here, it can be an enlargement or a reduction, right? Enlargement meaning make it bigger, reduction make it smaller. So what we're going to do, again, it's a distance from the center of dilation that is important. So why don't we find what is the distance from C to P? Let's find out what that is. Now remember, seeing I didn't put a segment over the top or a line, that does mean distance. So let's see if we can figure out what that is. And I've tried to make mine the same as your metric on your protractor. So that'll be the inside of your protractor. So you just want to line it up the best you can from C to P here. I got it lined up pretty good, I would say. And I'm looking at, if I'm lining it up, I'm lining it up right about there. And that looks like about 66 or 66 millimeters or 6.6 centimeters. So we'll go with 66 millimeters. Okay. Now for us to dilate for a scale factor of 3/2, we're going to do the same thing we did on a previous. We're going to take this distance right here and multiply it by 3/2, otherwise known as 1.5. Well, if 66 is the 1, then half of that is 33. So we just kind of add a 33 on top of that. So what I'm going to do is I know now my distance from C to P prime, where P has been moved. You know C didn't move, right? C stays. But P prime is going to get moved somewhere. And how far should P prime be from C? Well, 1.5 that distance. And so that would actually be 99 millimeters. Because if I took 66 times 1.5, I would get 99. So what you might want to do is, and some people do this, is they actually draw that line in, if I can get this to work. They draw that line in so that when they come up here, they can and actually go and measure the 99, they actually have some place to write it down. Okay, make sure you've got your ruler lined up there, or your protractor for you. And then we'll mark off, where is 99? Well, here's 90, and then there's 100, so 99 is right about there. You can see that I've tried to line it up with that 99th mark there. Okay. And so that point right there is P prime. Okay. So again, it used to only be 66, now it's 99, 1.5 times the distance from the center of dilation. And that's normally the hardest thing for people. So why don't we go ahead then? Again, feel free to pause this at any time I'm going on, because I don't have anybody really to reference to see if there's any questions. And if there is, I'm sure perhaps a classmate can help you. Obviously, I'm not here right now, so I can't. So let's measure that. I'm going to do, this is C to Q now. Right? So maybe I'll write it down here. C, is that a Q? Yep, C to Q. Well, we need to know how far that is. And according to mine, from C to Q is looking, mine's about, I don't know, 36-ish, because I'm looking right about there. And depending on yours, you might have 36, 37, I think, in years past is about what we've had. I think what I'm going to do is I'm going to use 36. That was or 3.6 centimeter, but we'll use 36 millimeters is what we'll use. Okay. So once again, it's probably in your best interest to kind of get that line so that you have something to mark off on. And it's really going to help you in a minute here when we go to do another one to have that line in place. So if you didn't have it on the first one, maybe have it for the next one. So there we go. I got that pretty well lined up. Not perfect, but it's pretty good. Move over a little bit. So we got 36. So now what I need to figure out is well, how far would it be from C to Q prime? Once Q has all been done and moved, how far would it be? Again, our scale factor is 1.5. So take 36 times 1.5, and that will tell you how far out that would be. Well, half of that is 18, so if I add that on top, that would be 1.5. And so what would that be, 54, I believe? 54 millimeters. So we need to figure out, well, where exactly is that? Okay, so 54. Well, here's 50, and there's 55, so 54. Probably, whoa, and there I go again, making my points really big, which is not very helpful if you want it to be accurate. So 54 is right about there. You notice once again, I'm looking right there is where 54 is. Okay. Again, notice how I am always going from the point C. So if I get this out of the way, that will be point Q prime. You might be wondering, is it okay that it's inside the pre-image? Our original PQR, yeah, it's fine. That's just where it happened to end up. Okay? And of course, then what we're going to do, once we are done with that one, is try the exact same thing for R. And maybe what you want to do is just get your protractor on and just give yourself a big old line right off the bat so that you got something to use. And measure from, ooh, that's really good. That's pretty good right there, the center of the point there. And from Q to, or C to R, excuse me, C to R, looks like about 58-ish. It's kind of in between there as well, isn't it? Well, I'm going to go with 58 this time. It looks like it's right about there, 58, right? So we're going to say that from C, hope I haven't been saying the wrong letter the whole time, C to R is 58 millimeters. Now it's okay that it's close to what CQ prime ended up being, not a problem. So now I need to find out, well, how far is it from C to R prime then? Well, from C to R prime would be 1.5 times that. And 1.5 times that is going to be, oh, I don't know, if we had half of that, we're looking at maybe about, what, 87-ish? Is that about what we'd end up with? So let's see, because half that'd be 25, 29. So yeah, about 87 sounds good. I can correct anything that happens to be wrong in my statements. I'm hoping that I have these correct here. 87 then is what we need to find. Notice once again I would just line up my ruler on that same line and find 87. I would say it's right about there. All right, and that would be R prime because that's where it ended up. And now what we would need to do is connect those points to see our triangle, and then we will see what we think. That looks pretty good. Looks a lot like the beginning one. It is very similar to the beginning one. So believe it or not, the angle measures will be preserved. Angle Q and angle Q prime would be the same. Distances not preserved. Collinearity preserved. Orientation preserved. Size or distances not preserved. From P prime to Q prime not preserved. Okay? P to Q is not the same as P prime to Q prime. Okay? Now I believe on yours for part B you were also asked to do a scale factor of 1/2. Now I could switch to the next page, right, which is where I actually have that problem. But really I have all the information I need already on this page, if that's okay with you. So why don't we just do it on this page, because we already have, whoops, and I was bound to do that at some point. We already have all our lines that we need. So why not go ahead and just use this page? Because we already have that one in there, and you should already have, well, if I can hit them, there we go, that one, and that one already drawn. So now what we're going to do is, instead of making a scale factor of 1.5, we're going to make a scale factor of 1/2. That's what your second one was, so we're not going to use that anymore. We're going to use a scale factor of 1/2. So this is letter B. Okay? So we already know that from C to P, right up here, we know from C to P is 66. So from here to there is 66. So all we need to do is figure out, well, what would half of that be? And that would be 33. And so then from C on that line, and hopefully I can line this up, I would have to mark off only 33 this time. And so maybe we'll do this one here. So 33, 31, 2, 3 is right about there. Now, does that mean I mark them all 33? No, not really. And you can call that whatever you want, but let's probably keep it some form of P. So we'll just call it P double prime is fine in this case if that's what you want to use. Or if you want to name it something else, that's fine. But I would like to keep it to know that it's part of P. Okay? And then we found out earlier that our distance from C to Q is 36. It's down here in the red, right? C to Q is 36. So we'd have to find half of that, and I believe half of that to be 18. Whoops, I moved that. Whoa, hey, slow down. Oh, there we go. Is about 18, so we'll move that over there. And we got to mark 18 then. So again, from that center of dilation, so 18 right about there. Okay. And then we know down here that C to R in green is 58. So we need to do half of that. Well, half of 50 is 25, like we did before, and half of 8 is 4. So if you add those together, half of that is 29. So we'll have to mark it 29. So now some of you are saying, why didn't we just mark these both off when we had them both on there? And that would be a wonderful idea, to just mark both distances as long as you don't get confused. So we've got 29, right? Is that what he said? Yep, 29. So that'd be right about there. It's 29. See, 29 right there. All right. And so again, I whoop, and then I just erase the whole thing. 29 right there. Let's get this thing out of the way. And I should have labeled this other point here, so we'll label this one here Q double prime and R double prime so that we can see it. And then what you're going to do is you're going to go ahead and you're going to use your straight edge to connect those. So once again, the angle measure was preserved, distance not preserved, orientation's fine, collinearity's fine. Okay. And so there is basically a triangle half the size of the other one is P double prime, Q double prime, R double prime is half the size of the original. And P prime, Q prime, R prime is 1.5 times the original. Okay? So again, the key is that center of dilation, or sometimes called the vanishing point, and maybe you can kind of see that now in an artistic setting. Okay? And hopefully if there are any questions, they can get answered. All right, we already did that one. Okay, so this one here says for each figure, a dilation with the center at the origin, I told you that would probably happen, produced the dotted line. So there was a dilation that produced the dotted line. That means the dotted line, in this case, is the image because it got produced. So that means then the solid line, so the dotted line is the image, that means that the solid line was where they started. And so the solid line must be the pre-image. That's how I read that, because I was told that that dotted line got created. Okay, so in this case, and some of you are probably thinking, boy, if the scale factor is bigger than 1, it probably makes the object larger. And if the scale factor is less than 1, like between 0 and 1, it would make it smaller, and you would be correct. So this one here, it is making it smaller, so I'd expect this to be a scale factor less, between 0 and 1, I should say. So one of the easiest way to find scale factor, and we'll call it K, that's why we normally see scale factor, is to take a measurement from the image and then take the corresponding measurement from the pre-image and put that underneath. So on this one, there's lots of distances we could find, but I would suggest if this is the center of dilation, which we've been told that it was, well, this distance from here to there is quite easy to find. It's 1, 2, 3, 4, 5. And then let's find the corresponding, so that would be this distance. And on this one, that is 10. So now we have to be very careful. Which number goes where? Well, K equals something over something. So either it's 5 over 10 or 10 over 5. It's hard to tell. That's why we have image over pre-image. So the image is the one that got created, which is the dotted line. So that goes on top over the pre-image, which was the solid one, which is where we started, which is 10. So our scale factor for this one is 1/2. Okay? So we've got half the size of what it was before, and you can see that. Okay? So why don't you take a second and try letter B of this one, which is on the back, what do we got there, a hexagon. So why don't you go ahead and try and find once again, the dotted line is the one produced. So that would be the image. Okay? So it started with the blue one and ended with the red one for up here on the smartboard. I know it doesn't look that way on your notes, but take a second to try that one. So again, K is image over pre-image. Okay, so you had to pick some measurement on here and then find a corresponding. So I would probably go in some particular direction that would make it easier to determine. I think it's kind of difficult to go up and down on this one, so I would once again just find one that I know for sure. I would say I know this distance for sure. That distance there is 2. So go with the corresponding, so that means you go the same way from the center of dilation. Once again, we were told it was 0. Notice I'm being very careful to use the center of dilation. You should do the same. And that is a distance of 4. So now we have to figure out which one goes where. Well, The dotted one again is the one produced, so that's the image. So the image is the dotted, so that's 4 over 3, which is 2. So my scale factor this time is 2, which means that the pre-image is going to be, well, the image, I should say, is going to be twice the size of the pre-image. Again, you can kind of see how they all got dilated out by a factor of 2. And yes, I use GeoGebra to do that, because GeoGebra can do that. Now, your example 3 is a little bit different than the one on my notes, but we can still do it. This is now saying, wow, that's really big. Determine the measure of the dilation image of segment AB. So they're saying you have some segment AB somewhere with the given scale factor. So that you can see K is in that. So AB on letter A here, you notice AB has nothing over it, right? No segment or anything. So 4 is apparently the distance from A to B, right? And they're saying that there's a scale factor of 5. Okay, so if AB used to be 4, scale factor of 5 means it should get larger in enlargement, and by a factor of 5. So all you have to do is say, well, what would be the measure of the image? So we would say that you could maybe say like A prime, B prime, which is where I would end up, would then be not 4 units long, but 20 units, okay, would be from the center of dilation. Okay. And the one that gets a lot of people is when the scale factor is negative. Okay? So if AB is 7 units long, if you just follow the rule, then you would say that A prime B prime is negative 14 units long. But we've talked about distance many times in here, and distance is not negative. And so what you can do is simply multiply by the absolute value of scale factor is what you can always do. You don't have to worry about the negative or positive on it. So in other words, you can just take the absolute value of that, so it's 2. So in other words, the distance from A prime to B prime would just be 14. So don't be worried about negatives on a scale factor. Again, hopefully if there are any questions, they can get covered. Again, one of the biggest things is realize that what you're trying to find is the distance from the center of dilation to your points, and then the corresponding points after they've been dilated. Again, enlarged or reduced. Okay. Good luck.